Hello, chemistry fans, and welcome back to Chemistry Problem Solving Session here at the Academic Success Center for Chemistry 1032. I am your host, Dr. Russell Betts, and I will be guiding you through this problem today. Define the following terms: strong acid, weak acid. Okay, well, these are actually very common definitions in chemistry. They're very easy to understand. First of all, before I define these, let me just talk a little bit about electrolytes. Let's think back to an earlier chapter where we learned about strong and weak electrolytes. We learned that a strong electrolyte, when put into water, will ionize completely. That is, dissociate, form cations and anions completely in water, and not have any of the parent molecule. For example, sodium chloride is a strong electrolyte. You put it in water, you get sodium cations, chloride anions. You have no sodium chloride molecules. Now, a weak electrolyte does not dissociate completely. And a great example of a weak electrolyte was the acid hydrogen fluoride, or hydrofluoric acid. We're going to learn a little bit more about that later on in this course. That molecule does not dissociate completely in water. So in water, you'll have the parent molecule, say hydrogen fluoride, hydrofluoric acid, and you'll have a little bit of H+, a little bit of F- is how we defined it then. We're going to change it a little bit today. So again, strong electrolyte dissociates completely in water to give you a cation and anion with no parent molecule. A weak electrolyte will dissociate a little bit in water. You'll get a little bit of cation, a little bit of anion, but mostly the parent molecule. That's a weak electrolyte. Now, we can apply these terms to acids. But now we have to be specific. The cation being formed is either going to be hydronium, which is how you should do it, or you could say H+, which is not as correct. Okay? So the strong acid and a weak acid are both going to form hydronium in water. Okay? The strong acid will dissociate completely with no parent molecule. The weak acid won't. Okay? So strong acid forms hydronium plus the conjugate base in water with no parent. I guess we could say parent. With no parent molecule, and you should read that as no parent acid. Okay, so the original starting acid is gone. So a great example of a strong acid, one that probably everybody knows, HCl. Hydrochloric acid is a strong acid. Okay, so there we have the expression for hydrochloric acid dissolving in water. Now, notice how the arrow goes to the right, and there's no arrow going back to the left. So this reaction is completely going to the right. So when you put hydrochloric acid, or HCl, in water, you form hydronium and chloride. There's none of this in the water. There is none. Absolutely none. It's only this and that. So the parent molecule gets completely dissociated or completely ionizes. Okay? No parent molecule in solution. Only this, hydronium and chloride. So only the hydronium and the conjugate base in solution in water. Okay? A strong acid will dissociate completely to give you hydronium and the conjugate base. There will be no parent molecule in there. Okay? Now a weak acid is just like a weak electrolyte. It forms hydronium plus the conjugate base in small amounts. Forms it in small amounts. It's mostly, or made up mostly of, or let's just say a lot of parent molecule in solution. We'll say it like that. So in a weak acid solution is very similar to a weak electrolyte. You form a very small amount of cation, hydronium, a very small amount of anion, the conjugate base, but a whole lot of the parent molecule exists in the solution. So for example, everyone likes to use HF as an example, so I'll just use it as well, plus H2O. There we go. There's an example of a weak electrolyte solution. Notice I have two different arrows here. I have one going to the right, one going to the left. What this tells us is that this reaction goes to the right, but now these two things form and they react backwards to go to the left. So it's in what's known as equilibrium, which we'll discuss in this class a little later. Equilibrium means that the rate of formation of these two products is the same as the rate for the two products to react backwards to give you starting material. So as fast as you make this is as fast as you lose it. So it's called equilibrium. So the concentrations of this and these two things won't change. So this is a weak acid-base reaction. How do I know it's weak? The arrows pretty much tell me. So in a solution of hydrofluoric acid, there'll be a little bit of hydronium, a little bit of fluoride, and a whole lot of hydrogen fluoride. There'll just be a lot of it in solution floating around. Okay, so that's the difference. Now, it's just like weak and strong electrolytes. Same definition, really, except now when you're talking about acids, you're always going to form hydronium as the cation. Okay, so that's a weak acid and a strong acid. And with that, I hope that we've been helpful to define these terms for you. I hope that it's a bit more clear if it wasn't clear already. If it's not abundantly clear, please contact one of the tutors here at the Academic Success Center, or come and see me or your professor during their normal office hours. Do not let these terms slip away because they're very common and they're used quite a bit, not only in chemistry, but also in biology and biochemistry. All right, now with that, I'd like to wish you good luck and good chemistry.